gravitation. The force of attraction between any two objects in the universe is called gravitation. The force of attraction between the Earth and any object lying on or near its surface is called gravity. Newton's universal law of gravitation states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. F is equal to g m1 m2 by r square. Gravitational force is a weak force unless large masses are involved. Acceleration with which a body falls towards the center of the earth is called acceleration due to gravity. The force of gravity decreases with altitude. It also varies on the surface of the earth, decreasing from poles to the equator. The weight of a body is the force with which the earth attracts it. Mass is the quantity of matter contained in the body. The weight is equal to the product of mass and acceleration due to gravity. W is equal to mg. Mass of a body does not change, but weight of a body may vary from place to place. Weight of an object on the moon is 1/6 time of its weight on the earth. All objects experience a force of buoyancy when they are immersed in a fluid. The total force exerted by a body on any surface in contact with it is called thrust. The thrust acting per unit area of the surface of a body is called pressure. The upward force acting on a body immersed in a fluid is called upthrust or force of buoyancy, and the phenomenon is called buoyancy. Archimedes' principle states that when a body is immersed fully or partially in a fluid, it experiences an upward thrust equal to the weight of the fluid displaced by it. The density of a substance is its mass per unit volume. Relative density is the ratio of the density of the substance to the density of water at 4 degrees Celsius. Relative density has no units. Mass by volume. Activity. Aim. To observe the behavior of an iron nail when placed on the surface of water. Materials required. A beaker filled with water. An iron nail. Procedure. Fill a beaker with water. Take an iron nail and place it on the surface of the water. Observe what happens to the nail. Observation. The iron nail will sink to the bottom of the beaker as iron is denser than water. Precautions. Make sure to handle the iron nail with care to avoid injury. Ensure that the beaker is stable and placed on a flat surface to prevent it from tripping over. Do not pour too much water into the beaker as it may overflow when the nail is placed in it. Activity. Aim. To compare the behavior of a piece of cork and an iron nail of equal mass when placed on the surface of water. Materials required. A beaker filled with water. A piece of cork. an iron nail of equal mass as the cork. Procedure: fill a beaker with water. Take a piece of cork and an iron nail of equal mass and place them on the surface of the water. Observe what happens to the cork and the nail. Observation: the cork will float on the surface of the water while the iron nail will sink to the bottom of the beaker. This happens because the density of cork is less than that of water, whereas the density of iron is greater than that of water. Precautions: handle the iron nail with care to avoid injury. Ensure that the beaker is stable and placed on a flat surface to prevent it from tripping over. Use materials of equal mass for accurate comparison. Do not pour too much water into the beaker, as it may overflow when the cork and nail are placed in it. Activity Aim: to observe the change in elongation of a rubber string or reading on a spring balance when a suspended stone is dipped in water. Materials required: a piece of stone, a rubber string or a spring balance, a container filled with water. Procedure: tie a piece of stone to one end of a rubber string or a spring balance. Suspend the stone by holding the balance or the string as shown. Note the elongation of the string or the reading on the spring balance due to the weight of the stone. Slowly dip the stone in the water in a container as shown. Observe what happens to the elongation of the string or the reading on the balance. Observation: as the stone is dipped in water, it displays water equal to its own volume. This reduces the weight of the stone, and as a result, the elongation of the rubber string or reading on the spring balance decreases. Precautions: handle the stone with care to avoid injury. Use a stable container filled with water. Ensure that the rubber string or spring balance is securely tied to the stone. Record accurate measurements for precise observations.